So let's get on with a bit more of this simplifying expressions, and now we're going to try and we're going to work on the questions which are more traditional to what you might see on an exam paper. So away with the walls and the diagrams, and let's just get into it. I have on the screen, and you can see some examples. I'm going to work through a couple of examples as well, but you can see if I have a plus a plus a, I'm adding 3a's, so that's 3a. If I have a plus b plus a, how many a's? You're collecting the like terms only, so it's 2a's plus b. Similarly, I have 2y's and 8y's. In total, I have 10y's. And then the final one, that's going to come into the next task more so. When we have the squared terms, pay particular attention to what's happening here. You might be tempted to look at this and think, wrong, I want a pen, don't I want a pen? Yeah. That x squared plus x squared, and what we're trying to get across, look carefully at this, is that squared terms are different to the terms without the power, without the squared. So what you have is x plus 2x squared, okay? They are not like terms, you can't collect them. And the reason behind that is, let's say suppose, I'm using right language, suppose I told you that x is equal to 3. Then what did we start off with? We started off with substitution. I want you to work out, I would say evaluate. So this is a question I want you to do. Suppose x is 3, then evaluate x plus x squared plus x squared. Go on, work that out. What do you get? Evaluate x plus x squared. X plus x squared plus x squared. Then for the second one also, evaluate x plus 2x squared. So do those two questions. What answer do you get? What answer do you get for each of them? And you should pause and you go through. And for the first one, and let me make some space. You still have a chance to pause if you haven't done so. That is critical to your success on this course, that you actually engage and try questions for yourself. We're really dependent on you doing that. I'm just going to make some space here for the second question. Question number 2. X plus x squared, x plus 2x squared is what I wanted. Right, so let's look at what happens here. X is 3, so I have 3. Different color is what I required, so I'll do it blue, 3. And then x squared, what does that mean again? Do you remember from previous work? X squared means x multiplied by x. In other words, in this case, it means 3 multiplied by 3. 3 multiplied by 3 is going to give me 9. 3 multiplied by 3 is going to give me 9. So what do I have? I have 12 plus 9, which will give you 21, or 18 plus 3, 21. Okay, so x squared plus x squared plus x squared is 21. Then let's look at the second. We're saying that they're equal. Okay, x plus 2x squared. What do we get? X is 3. Then 2x squared. Rules of indices says, what do we need to do? X squared, we do BIDMAS, I for indices and BIDMAS. So we have 3 times 3 giving me 9, and then the letters and numbers together means we have to multiply. So you have 2 multiplied by 9. And again, BIDMAS, we did the indices first, evaluated it, worked it out. 2 times 9 is going to give me 18. So what do I have? 3 plus 18 as before, giving me 21. So you can see for yourself by evaluating. We don't know what the value of x is, but we've supposed x is 3, and we can see that it works. The expression on the left is equal to the expression on the right. Now, what might you have wanted to do? What I have seen in quite a lot of times is somebody would look at this expression and they would say that the answer is 3x squared. That's not an uncommon answer we'll get. But what would happen? Let's think. If you said it was 3x squared, what would happen is that you would have to do x is 3, so 3 3s are 9. You will get 3 times 9, and 3 times 9 will give you 27. It does not work. And I've just spent time looking at this so you can appreciate, and if you're not sure in an exam context, a lot of the ideas I'm trying to push to you is experiment with numbers that you're comfortable with and see what happens to see if you're correct. Okay, so rules of indices, collecting like terms, and if you have terms with powers, they must stay separate from the term without the power. It doesn't matter if the letter is the same. If there's a power, x squared has a different value. In this case, x is 3, but x squared is 9. They're different terms. They have different values, generally speaking. Not all the time, That could be another question. Should I? Yeah, okay, we're going in. But if I said x is equal to x squared, what's x? So bonus question, because I mentioned that x squared will have a different value to x most of the times. Give me a number for x in its first situation where x has the same value as x squared. Come on, give me a number. Are you thinking what I'm thinking? Yeah, you got it. Yeah, 1. 1. If x is equal to 1, then we have 1 times 1 is 1. So x and x squared have the same value when x is equal to 1. Okay, so that's one of those special circumstances. But in general, x squared and x have different values, or x cubed and x have different values, etc., etc. Let's use these techniques to do some questions. Let's do some simplifying, and then once we're done with the simplifying, then we can start building on our expanding brackets, which is our target. That's where we really want to get to, expanding 3, 4, 5, I don't know, loads of brackets. We want to get to that, and we will get there as we continue. Simplifying expressions, 2 questions. As usual, I empower you to have a go. I put 4 E1 because they're examples, but you can actually work through the examples before I do. You can pause and go and then feel, yeah, I know how to do this. That's a feel-good factor you want. So we have 4A plus 3A. Note what I'm doing. I've written down. You should have written down the expression. Don't just go into answers. So let me model totally. What are you doing? In your book, you would write down 4A plus 2B plus 3A plus 6B. Before you wrote that down, just to be clear, you should have written down task 4 and the objective for task 4. So you're just creating this clear record of what you're doing and how all the questions tie up to each other. So 4A plus 2B plus 3A plus 6B. And then you look for the like terms. Do I have A's? Yes, I have 4A plus 3A. In total, note I'm taking the sign in front of 3A, and that means in total I have 7A. Don't know the value of A, but it does not matter. I know I have 7 lots of this A, and messages are coming up that gotta close that off, but I'm not gonna let that distract me. Mute the sound, and that's sorted. Right, the other bit, let's look. I have 2B plus 6B. Note I'm just color coding and just matching everything up. I have 2 B's and 6 B's. In total, that means I have 8 B's. So 7A plus 8B is my final answer when I simplify. Didn't need to write down that equal sign. I was just writing down the expression. For part B, have you done B? After I've done A, have a go at doing B. First bit you should be doing, I'm looking for x's. I have 3x plus 2x. Then, the ugly thing, I have minus 4y minus 2y. Are you doing that matching up? Those are the 2 calculations we need to work out. 3x plus 2x, what does it give you? 3x and 2x will give me, that's right, it's 5x. And then take away 4y, take away y. What is this y? Take away y is the same thing as take away 1. Let's stick with the color, and I'll write it underneath. Take away 1y. So what it is minus 4y, take away 1y. Make a bit more space for my 5x. Yeah, so we have that 5. We have 5x. And if I start at minus 4 and I go down 1, I'm thinking number line, start at minus 4, go down 1, I get to minus 5. I get minus 5, so it's minus 5y. 5x minus 5y is the solution to this problem. 5x minus 5y. You got them right, you're smiling. You did get them right, then you should start smiling. Eventually, that's what we want to get to, because you're looking at it and saying, okay, right, I get this method, I can do this. And can you do it? Let's see. Here are 4 for you to do. I'm saying T for try. This is for you to have a go. 4 questions. Don't worry about the letters. I just did the odds, the right-hand side of an exercise. So B, D, F, and H. All of these are in the MEP Unit 11, Year 9 MEP textbooks. But you don't need, if you're following the videos, all the questions that you're doing are posted on the video just to make it a bit easier, particularly if you're on a mobile device, so you don't have to be switching between a PDF and the screen. You can work off the screen. So These are the 4 questions I'd like you to try. Pause, have a go at them. I'm going to pop up the answers to them at this stage. If necessary, based on feedback, we'll look at me doing more examples, but you have some examples for me to look at, and I'm going to provide the answers for these for you to mark your work. So please keep trying. I'm looking for those answers here. Where is my answer book? I think I closed it off. Actually, no, it is here. Okay, right. So you paused, you had to go. The answers are coming up now. The answers are coming up. I'll write them in red. Mark your work preferably in a green pen. I just need to make sure I find the right exercise. And yeah, so the first one, you should have 10b plus 5c, 10b plus 5c. Then for D, please mark your work. You should have 6p plus 14q, 6p plus 14q. For F, you had the 11x. Was there any more x's? No, so it stays as 11x. Then the y's, let's look at it. I'm doing this one. You had 8y, positive 8y, take away 2y, take the sign in front of it. 8 take away 2 is 6, so plus 6y, positive 6y. And then the z's, if we look at the z's in blue, plus 3z plus 4z. In total, you have positive 7z. So that's the answer you should have had for F, and have gone through the process you should have gone through there. And then finally for H, following the same style for H, what I'm seeing is you should have 3, I'll put the answer in red, 3y plus 16z. Let's say that again, 3y plus 16. Do you say Z or Z? I'll go with Z. It's 3y plus 16z. So there you have it. You had a chance out of this to do 6 practice questions, the examples and these, and plus, so you have this to mark. And the bonus round, bonus wrong question. Let's just think about this. If I told you now that x is equal to x cubed, what's x? What's the value of x? If somebody tells you x is equal to x cubed, what is x? Are you thinking what I'm thinking? Are you thinking what I'm thinking? Yeah, x is minus 1. Oh, did you think about that? Did you think about that? Try it out, see. And then the question I'll ask you, is that the only answer? So see, don't think that, oh, all the work is easy. Stick with these videos. We'll throw out some interesting things there. You'll be surprised at what you start learning as you spend more time going through stuff. So x minus 1 would work there. What's the other number that would work? I put this one because I don't think it's the one you were thinking. Listen, if you were thinking this, email me or one of the other lead teachers on this project and tell us. I want to know. I'll take your word for it. If you were thinking about minus 1, I am very, very, very impressed if that came to your mind. Good stuff.